G'day Internet, welcome to another episode of Morgan Makes. My name's Morgan and I hope you're having a fantastic day. Today in Australia it's Father's Day. Hi Dad, I love you. So the cool thing about fathers is they always tell you what they want for their birthdays or Christmas or in this case Father's Day. Dad does a lot of things with antique fishing rods and such, so he wants a fishing rod lathe thing for turning the little bits of string and resin and stuff around the eyelets here. So, let's have a crack at designing one. So today, as I said, in Australia it's Father's Day. My dad likes to go fishing. He likes to go fishing a lot. In the Greater Sydney Basin here we have hundreds of great fishing spots, and over the decades he's probably visited most of the publicly accessible ones and more than a few of the private ones. He likes fishing so much that he makes his own lures and restores antique fishing gear. So the other day he asked me if I could build him a rod turner. He showed me a picture on his phone for about 5 seconds. This picture actually. It was long enough for me to get an idea of how this is going to work. So that's the challenge. Kind of like one of those painting from memory things. So no research allowed. I'm not going to look at the source image again until the project's completed. Okay, so how does it work and what does it do? It should turn a fishing rod like a lathe to wind up eyelet strings and to set resin smoothly. Seems simple enough. From memory, the device has 2 parts, a motorized section to turn the rod and a passive bearing section to hold the other half of the weight. I don't recall seeing a spine or any kind of trestle that the 2 parts are attached to, but I'm going to design one that uses it anyway because I think it will be easier and a little bit more sturdy. For the spine trestle part, I will be using this 55mm aluminium box section from a pile of scrap metal. It needs a quick clean, but I don't think it's going to need a spray. I recently learned how to print in TPU rubber. I've only been trying to print in this stuff on and off for about 10 years now, and now I've finally succeeded. It's awesome. Using Blender, I designed some end caps for the box section. I printed them out in the TPU rubber just so the ends wouldn't be so sharp and stick into things. And they just friction fit on. I want to keep the box section empty in case Dad wants to store anything in there. So the main trestle spine part thing's done. Well, that was easy. Now onto the more complicated parts. Not all fishing rods are made equal, and they are definitely not all the same length. So I want to make 2 modular sections that are able to clamp onto the box section. Again in Blender, because that's what I know how to use, I designed this kind of double vice clamp thing. This will be the base for both of the modules, and it will probably work for any other type of modular attachment that you could think of for the system. The more I think about it, the more I think up. Think about it. So I designed and printed out a bunch of parts. Let's have a quick look, shall we? Like my coin? It's helping me keep my new camera in focus. I'm still learning how to use it, so bear with me. Right, back to the 3D printed parts. We have these 2 parts here that fit over the 55mm box section with holes for the screws and the vice clamp. Next up is the screw risers. This part was fairly unnecessary. In hindsight, it was a kind of a silly idea, but we'll get to why in a bit. The next parts are the covers for the vice clamp. They have the threaded interface for the vice screws. Now, because I'm a dumb, when I designed this, I made one that works as it should, and then I mirrored it. So now one of the screws turns the wrong way, but whatever, I'll fix it for the next revision. Next is the screws for the vice. Again, they turn different directions, so I went back and marked the parts with a triangle and a pentagon so I can tell what belongs to where. And up next is this little cup part that sits on top of the screw riser to hold the module. They have this shaped cutout in them for the screw riser to pass through, and then it gets screwed in. These ones. You should be able to see kind of what I'm going for here. And last but not least, the riser nuts that hold all the threaded shaft parts in place. So that's all the parts for the bases. Basically you'll need 2 of everything. So now for the one-offs. Starting with this thin little screw that's going to be the bearing guide clamp mechanism thingy, and then the bearing guide clamp holder. Kinda looks like a duck, don't you think? And here's the other part of that assembly. It has a threaded nut and a guide to slide into the clamp. For the other side, it's just the 2 halves of the motor control box and the electrical housing that I designed. By the end of this, one of them would be butchered and one of them would be replaced. All of these parts were printed in PLA at a 0.4mm nozzle width and a 0.2mm layer height at a 10% infill. And now onto the TPU parts. That's the end caps we saw before, the main rod holder part with integrated geared toothing. I needed a couple of tries at this part too. Gears are hard, man. Kinda looks like a lightsaber part. That's my first prototype of the main drive gear. The final design uses one made from PLA to reduce the slippage on the shaft. Man, this sounds dirty. Some rubber feet to hold it down. They need to be taller, but they work as a proof of concept. These little rubber caps at the end of the vice screws to hold everything to the box section. Some tires for the bearings that I didn't account for in the PLA design so they don't fit. another part that I'll need to redesign at some point. And finally, some little rubber spacers to keep my bearings straight on the bolts. Speaking of bolts, what about the hardware? For all the little screws, I'm using some 4G by 9mm sheet metal screws. 3 bearings, I'm using just some I had on hand. 3 M8 by 30mm nut and bolt sets with 2 washers apiece. 4 M4 by 30mm nut and bolt sets with 2 washers apiece. And for the electrics, a little covered rocker switch to turn the power on and off. A DC female barrel jack that I can just plug a 12V supply into. A little 12V DC motor. I got this one out of an inkjet printer that was junked. The motor is responsible for the paper feed, so I know it can take a load if properly geared. I had planned on using a MOSFET controller with a potentiometer, but while I was cleaning I found a better solution. It's basically all the parts I just showed, but all together on a single board. It was one of those little soldering practice exercises you get from JCar. It wasn't in the initial design, but we'll get to that in a second. So that's all the parts, let's put them together! Starting with the base clamp and the TPU feet. They have this little plug on the top, so they just pop into these little holes. Then you take this bit and screw it into this bit and attach that there. 6 screws per side. Then do the same for the other side. Once that part's together, the vice screws are inserted. I had to make sure that they were matched up correctly, triangles and pentagons. Next up comes the riser. Using the M4 bolts, it attaches to the top and the screws in the side with 4 screws. I designed the shape to help prevent the force from the vice from bending the plastic base. The riser screw threads through the top of the little mounting cup and then screws into place. I kind of wish it was a little bit more snug, but that's for a future revision. Using the riser nut, they are locked into place. It still has a little bit of play, again, more refinement is required later. And once I'd made one, I just simply made another. Now this is where the twins will go live 2 separate lives. I'll do the passive side first because it's easier. So, start with the part that looks like a duck and it fits into the top of the mounting cup and then screwed down. The clamp screw and the clamp jaw are now added, and now it can clamp.
Gee, you think? You think that maybe I should use these clamps that I use every day at every opportunity? You're a freaking genius, you idiot!
I put the bearing tires on, but they didn't fit on the duck with them, so I abandoned that idea. I would have liked to have used faster spin bearings, as the ones I have are sort of meant for a more significant mechanical force, like a truck or something. TPU inserts go on each side of the inner ring of the bearing to keep it centered on the M8 bolt. I do this for both of the duck heads. Now the motor side. This is why planning is important. I would have suffered a lot less grief if I'd planned it out just a little bit more. This box had more than just a few iterations. I'm going to have to figure out something to do with all the parts that didn't fit. First up, the motor box screws to the top of the mounted riser cup, same as the bearing clamp, using the 4 G4 screws. I fit the M8 bolt to the box and mount the washer. I wasn't thinking about the assembly when I designed this part, so this was tricky. Once the bolt was in, however, I mount the bearing with its washers and spacers just like before. Now the TPU gear head should just slip onto the bearing with minimal effort. Oh, that turns nice. Looking good so far. My little 12V printer motor gets installed in the top plate of the motor box, and this is where it all started to go wrong for me. During some testing off camera, I discovered that my gears weren't meshing properly, and the TPU drive gear stripped off the motor axle. I did think I was filming this part, but apparently I don't know how to use the camera very well yet. Several iterations later, and I have a new PLA drive gear with more refined teeth. I also made this TPU seal for in between the 2 halves of the motor box to lift up the motor a tiny little bit and cut down on the chatter. Alright, so now we're back on track. But now my new control board won't fit in the original box, and I don't feel like printing a whole new one, so out come the side cutters to make some minor adjustments. And I'm going to drill a hole too, just for good measure. Alrighty, okay, now the board is fitted, it's time to wire it all up again, tighten everything down and see where we're at. The gears are still sticking, I guess I need to have another crack at that drive gear, but we're making some progress. So another drive gear iteration later, and the new gear works so much better than the old one. It has a much smoother rotation and a lot less noise. Cool, I think we're nearly there. And so I had that rocker switch that I showed at the start. Oh, well, it was a late entry, so I reprinted the top plate of the motor box, moved the motor and the drive gear over, stuck some of those loose parts down with some hot glue. Now time to see how she all turns. Yeah, that's looking good. That switch makes it a lot easier to test anyway. I'm going to try this 50mm hose clamp just to keep the end of the fishing rod in the rubber grip. Wow, that shakes a lot. Well, if nothing else I can use it as a paint stirrer. But another problem presents itself. The hose clamp is compressing the rubber holder and deforming it. Well, another redesign. This one has fingers. Has fingers that can grab and hold a rod and not deform as much under the hose clamp.
They call them fingers, but I never see them fing. Oh, there they go.
Changing it over was a chore, but once it was on I was happy. Well, now I can at least put the last screw in the top plate here and be happy with the motorized part now. However, it still wobbles an awful lot. My quick and dirty solution is to just add some hot glue to the tops of the riser screws at the mounting cups. That's the ticket. A few more bench tests and the final load test, and I think we're done here. I like it. Now looking back to the original photo that Dad showed me, I was way off. I overcomplicated things far too much. But it was still a fun build, and it taught me a fair bit about screw threads and gears. Yeah, I definitely want to use more projects in the future that use them. It still shakes a lot, and it may turn too fast for what Dad was hoping for. You know, I never actually checked how fast he needed it to turn. Maybe I should have done that. Now, if I was going to make a slower version, I would have just used a stepper motor and a direct drive, and I almost did, but I went this route instead. All I can hope now is that Dad likes it. And there you have it, folks. That was like 2 weeks worth of design and tinkering and all sorts of experiments, basically just slammed together into a single project. It still needs more revision and, you know, a little bit more tinkering and refinement before it goes out into a, you know, to be made available for the public. I'll do that eventually, though. So if you actually want one, let me know in the comments. Don't forget to like and subscribe. Share this content with your friends. My name's been Morgan. I hope you have a fantastic day. Take it easy, guys, and I'll see you next time. Cheers. Happy Father's Day, Dad.